A good user interface is one that minimizes the number of clicks and keyboard input. I'll teach you how to build a graph editor that does that. Now, in other courses, I've considered mobile as well, but in this series, I'll focus on the mouse because I think it's the best tool when creating graphs. It has two easy to press buttons we can use for adding, dragging, and removing points. We'll implement the editor step by step, adding new features when needed and polishing existing ones until we're happy with the final logic. At least I'll be happy with it, but if you're not, I hope you'll get the skills to edit things in or out just the way you want. Get it? Edit things? Because we're coding an edit? No.
Gonna code, debug, and have fun. Coding with Radu, coding with Radu. Gonna prototype and design. Coding with Radu, coding with Radu. Let's code now.
We will define our graph editor here after we have the graph. And we initialize it like so. New graph editor, passing the canvas. It's going to need that for event listeners and the graph. And it's going to also be doing all the drawing on the canvas. So actually, we don't need this call anymore. It's going to be handled by the graph editor. And the editor is going to be very interactive. It's going to change all the time depending on our mouse moves. And the simple way to implement this is using an animation loop. So a function that we call here and start to animate. And it's going to be really simple. All it does is it clears the canvas because it's going to redraw again and again. So clearing starting at 0, 0 and all the way to the canvas width and canvas height. And then we'll have our graph editor display itself. It knows where the canvas is because it has it here as a parameter. And finally, we call request animation frame and pass this animate call again and again and again. It's going to be kind of a recursive call where the browser will try to recall this function 60 times per second. So we're ready to implement this graph editor, and we'll do that in a new file. I'm just going to define it here in the main JavaScript folder. So it's going to be called graph editor. And in JS, create a new file, graph editor.js. The class is a simple class, and the constructor will get the canvas and the graph as parameters. Now let's set these values as attributes so that the editor doesn't forget them. And let's have a reference to the canvas drawing context as well, defined here as a class attribute so that we have easy access to it, like so. And the display method, for now, let's just have it draw the graph on this context. Save the file, refresh the page, and it looks pretty much the same as before. But now if you go to the console and you type, for example, p1.x is equal to 400 and press enter, you're going to see immediately that point jump to a new position because it is rendering again and again and again all the time. You just don't see it. So we are ready to start adding event listeners for the mouse action. I'm going to create a private function, private method for this here. So it starts with the hashtag and then add event listeners. And this method is going to be here below the constructor. The first event listener we add to our canvas is going to be for mouse down, and we get the information from this event and write the arrow function. So this arrow function, let's close it here and now implement the body. The first thing we'll do is get the mouse location from the mouse down event from the click. So mouse is going to be a new point, and the information is inside of this evt.offsetx and evt.offsety are the xy location of the click. Now with this point, we can just tell the graph to add the point and the code should work. So let's refresh and click somewhere, and there you go, points added anywhere we want them. So it's an improvement over the randomness we had previously. Now, one thing that we'll really need in this editor is the ability to select a point. And let's implement that so that the last point that we add is also selected. We'll have a more complex logic for the selection later, but now it's just like that to test. So I'm passing here, this selected is equal to the mouse. And this selected will be an attribute of the class. Initially null, it can be null if we don't select anything. And then in the display here, let's draw it separately in a different way. So if we do have a selected point, I'm going to tell this point to draw itself on the context, but this is just going to draw it on top of itself already. It's already there from this graph draw. So I want to specify a little bit different properties for this selected point. And let's give it an outline. We don't have this functionality yet. So let's save this, go to our point primitive here, and in the draw method, add an outline here. Now, the more parameters you add here, the more difficult it's going to be to remember their order. So I like to group these as an object, like this. And now you could pass them in any order you want. You just need to specify these properties, the name of these properties here, like what we just did. So if you want to pass this without these options, we write here equal to an empty object, and then you can just call draw as we did before in the graph. Now this outline, I'm just going to go here below, and if we do have an outline, we begin another path, set a line width of 2, for example, and let's give it a stroke style of yellow and draw a new arc at X and Y, but our radius will be a little bit smaller. I don't want it to be exactly the outline. I want it to be kind of inward. I like the look of that. So let's say radius times 0.6. And again, 0 to pi for drawing a complete circle. And again, if you want this selected point to look different, just make it different. It's your code now. Let's save this, refresh. And now when we click somewhere, we're also going to have that point that we just added selected. And this is how it looks like. And the next thing we do in our logic is when we click on a point that is already existing, I don't want to create a new point on it or close to it. So I actually want to select that point. And at the moment, this doesn't happen. It just creates a new point on top of it pretty much. So let's see how we do that. We first have to figure out what point are we hovering over. So going back to our graph editor in this mouse down event listener, after we have our mouse location, we get the hovered point by looking at the nearest point. So we're going to need the function getNearestPoint from the mouse from all the graph points, like this. And then if this hovered point exists, we are going to select it, like so. And now I'm going to return. So the code doesn't go here anymore for adding a new point and selecting it. It just selects it. Let's define hovered also in the constructor here, same as selected. Hovered, initially null. And what we need to do is implement this getNearestPoint somewhere. And what I like to do is create a new file and link it here in index.html. It's going to be also part of math, and we will call this new file utils.js. This will have utility functions, mostly math functions, that will help us during our project. So in math, create a new file called utils.js, and the function for getting the nearest point to a location from a set of points is going to be a basic minimum search. So we look for the minimum distance from our location to all the points and select the point with the minimum distance. We do that by initializing this minimum distance to a very large value like this, and the nearest point, let's just have it null in the beginning, and then we loop through all the points in the array like this and calculate the distance between that point and the location that we have here as a parameter. If this distance was found to be less than our supposed minimum distance, then minimum distance becomes distance, and we record the point with this minimum distance as well in this nearest attribute. Then we go here at the bottom and just return nearest. And what we still need to do is implement this distance function between 2 points. And this is really easy. We've done it countless times. I have a special video about it. It uses the Pythagorean theorem. And we just return the hypot between the difference on x and the difference on y between these 2 points. Let's refresh. And now when we click, you see it selects a point. It always selects the nearest point when we click somewhere, but we can click anywhere really, and maybe we would like to have a limit so that we are close to that point to actually select it, because at the moment we can't add new points anymore. We're always just selecting. So what we'll do is when we look for the nearest point, we'll check also if the point is under a threshold. So this third parameter, threshold, let's have it 10. I like to have it just a little bit bigger than the points so that you can click almost there and it's still going to work. And then here our if is going to check and the distance is less than the threshold. Then it does everything. Let's save, refresh. And now when we click here, it adds new points. But when we are close to something, it selects that point. And you can still get nearby points if you are outside of that threshold. But if you're close enough, you actually select it. Play around with this and let me know what you think. What should the proper threshold be? Now, our getNearestPoint function here should have this threshold as an optional value, really, because the name implies it's going to find the nearest no matter what. So the threshold here, I'm going to define it to be this very large value that we can use. And then in Graph Editor, when we get the nearest point, I'm going to pass here 10, like so. Now refresh the page and the code will work as before, pretty much. What would be really nice is to know if I'm going to click here, will this add a new point or will it select the other one? Are we inside of the threshold or not? And we should know this before doing it. Otherwise, we get surprised by what happens. So visualizing the intent is important, I think. And that's what we're going to do next. We are going to need to define a new event listener for mouse move this time. So mouse move. And on every mouse move, we are just going to take this hovered point like so. And here in the display, we will visualize this hovered point as well in another way. Let's copy these lines and say if hovered, draw the hovered one as well. And this one, let's emphasize it with fill this time. So fill set to true. And inside of the point, we pass now this fill as well. By default, it's false. And at the end here, I'm going to check if we do want this point to have a special kind of fill. We begin the path and we draw a new arc. Again at the X and Y, and the radius, I'm going to have it smaller this time. Full circle. And let's remember also a fill style. I'm going to set it to yellow. And instead of stroke, I'm going to call fill. Let's save this and refresh. And now when you move the mouse over the point, you're going to see the highlighted point. So you know if you see that once you click, it's going to select it. And if you're close but you don't see that and you're going to click, it's going to create the new point. So the interface is not surprising anymore. It's much more useful for the user. I don't like this point. I think it's too close to that one. So I would like to remove it somehow. And I'm going to implement removing of points by right-clicking on the points. We go to our graph editor in our mouse down here. And actually, we don't need this hovered anymore because it's already happening here on mouse move. So we could remove it entirely and nothing will change. Everything will still work. And to implement the right click, we're going to go here at the top and check if we press the right click or not. That information is also part of the event. And we do if event button is 2, this means a right click. And I write here a comment because I always forget which is which. Then if this hovered, I'm going to say graph remove point this hovered, like so. And the logic from here is if we have pressed 0, which is left click. Now you maybe know why I'm confused about these numbers sometimes. Let's save, refresh, and now when we right click, something happened. You actually don't see this, but I have this menu appearing on the canvas. And let's get rid of that. So to get rid of this right-click menu, I'm going to add here another event listener for context menu. And the function I'm going to pass is going to call prevent default. This is just going to prevent that menu from coming up. Now let's test again. Clicking on the same point. It removed the segments connected to that point, but not the point. Oh, also the point. But for some reason, the point is still visible until I move my mouse away from it. And that's because when we remove the point here from the graph, we still have selected and hovered there. You could do here a more complex code, or you could refactor this, saying this hashtag remove point, and now go somewhere here below and implement a private method for remove point that calls the same thing we had before. The method we implemented for the graph also sets hovered to null and selected to null to get the proper interface. Let's refresh. And now when I remove, it really goes away and no weird artifacts coming. Now, if you test this and, for example, remove this point, you see it also unselected that point. Any point that is selected will be unselected because we just said this should be null. But maybe we want that point to stay selected, not make the user have to work again if they want to select it again for some reason. So we can easily check for that here and say that if this selected is that point, then we mark selected as null. We don't have a selected point anymore because we removed the one that was selected. Refresh. Remove that and it's still selected. But if we remove this one, then it goes away and no weird artifacts are there. Okay, great. Does this work in all possible situations? Well, one thing that you'll notice is if you add a point here and right-click on it now, it doesn't remove it. It doesn't go away, even after I move the mouse. And that's because we're removing points that we hover over. Our hovered is updated here on mouse move, but when we add a new point, it's not yet assigned to that point, even though our mouse is hovering over it. So we could do that here, like so. And now creating a point and right-clicking on it will indeed remove that point as well. Small things like this are what makes an interface not just good, but really good, and people will choose you over somebody else making one. Now, correcting points is possible already. If we want this point to be a little bit more to the right, we just remove it and recreate it a little bit more to the right. But dragging would make this much easier to work with. So let's add drag functionality next. And in mouse down, when we hover over something here on left click, I want to also enable dragging for that point. So let's say this dragging is true. And this is going to be another attribute here, false by default. And as we move, if we are dragging, the selected point, X and Y, are going to come from our mouse location, like this. Now we also want to release of the point somehow, and I'm going to do that with another event listener here. Let's just copy the context menu, and this will be for mouse up, like this. And what we do in it is this dragging is false. And we don't really use this event here, so we can remove it. Now refresh, and if I'm going to click and drag, this works. So I can add points, I can drag points, and it works just as expected. So far, we've figured out the points, and it's time to move on to the segments as well. Create new segments. And when building roads, a very common thing, what you have to do is generate the shape of the road like this. And you really get a lot of help if the interface is going to generate a new segment between the current point and this new point that you're going to add at each time. So let's do that. We are going to go to this mouse down event listener, and here, when adding a new point, just before setting selected to that point, we're going to use the previous value of selected, if it exists, and add a segment between that and the mouse location. So I'm going to do this if there is a selected. Let's try to add a segment. A new segment selected at the mouse. And the reason why I have try add segment here is so that I handle things like clicking on the same point multiple times or clicking between the points multiple times, which would otherwise add a lot of segments that are overlapping or invisible or something like that. Now let's save, refresh, and if I start to click, you can see those segments added there just fine. But maybe I would also like to add a segment between things that exist already, like these ones. So let's copy this code also here when just selecting points. So before this selected is set to what is hovered, we try to add a new segment between this selected and this hovered this time. Let's save, refresh, and now I'm going to select this and this. Seems to work. Now, if I'm going to continue like this, at some point I have a problem because maybe I want to connect these 2 points next. And clicking this point or this point is going to add a new segment here, something I don't want. And the reason for that is I have no way of unselecting points at the moment. So if we would unselect points, we would unselect this one before clicking on this one. And then this weird segment wouldn't happen here. So maybe we go up here when we right click. And if we are not hovering over anything, we do an else. This selected is null. Okay. And now I'm just going to try to recreate a little bit that. Click somewhere else with the right click. And now I can click on this point and then this point and get the segment that I want. Now, the code that we have here is pretty much the same. This part and this part is identical. I'm going to implement a method for selecting a point. So this is going to be here, a private method, select point, and in it, I'm going to copy one of these. And pass this point properly. So instead of mouse, point. And now up here, this duplicate from here, we just remove and say this select this hovered. And here we say this select mouse. And everything should work the same as before. Selecting points, unselecting points, connecting them, everything pretty much. One thing that we did before for the points, this intent, showing what happens when you click somewhere, would be really useful for the segments as well. Like now we have this point selected, and if we would click here with the left click, it will connect them. But maybe we forget, or maybe the user is new and doesn't want that connection to happen, but he does it anyway. Then this is going to be annoying, because what the user has to do now to undo everything is pretty much remove this point and now recreate. Oh no, it selected that one because it was already selected. Remove this point, click it here, and connect it to that. So maybe the user just wanted to select this like so without having anything else selected. But if they don't see the intent that having this point here selected is going to create a new segment here, then they don't know that. They may be surprised by what happens, and then a lot of work is needed. So I will show this intent of creating a new segment somehow. For that, we need access to where the mouse is in the drawing section here. So I'm going to take the mouse from mouse move here and make it as an attribute of the class. So this mouse is going to be that. And I'm going to put this dot in front of everywhere we use mouse pretty much. And actually, the mouse that we calculate here as well, it's not needed because we moved the mouse before pressing it. So we're always going to have it more or less. And here, this mouse, this mouse, this mouse. I think this is all of them. And let's define it here at the top and set it to null like this. And with this mouse, we can go in the display here before drawing this selected node. And let's say we create a new segment from this selected to this mouse and draw it using the context. Save and refresh. And now when we have a point selected, you can see this line creeping out. So it does tell us that something is going to happen there. When you click here, it's going to create the segment on that line. And when you're going to click here, I would actually like this line to snap to that point. When I see that point hovered, I also want this line to appear there as well. So let's do that. We will get our intent as the hovered, if the hovered exists. Otherwise, the mouse. And now we pass here this intent instead of the mouse. Refresh. And now you can see that intent jumping there. But this segment that we are drawing here as the intent looks too much like the other ones. So let's make it look like a dashed line. I'm going to pass here also dash options 3 and 3 in an array. This means 3 pixels of line and 3 pixels of space. And save this. And we have to modify our segment primitive to show this as well. And this starts to have, again, many parameters. So I'm going to group them as an object as we did before. So dash, by default, it's going to be empty. And we do this so that we can just draw the segments without passing any of these parameters. Now the dash here, we set line dash to the given dash. And after we do the stroke here at the end, I like to copy this and reset the dash so it doesn't affect all following drawings. Many people like to use here context save and restore at the end so that everything gets reset, but I find it a little bit slower on my computer. Now let's test. And we can see that situation from before. So Anybody using this would know that clicking here would create that. But if they right-click and now click there, it selects the thing without any surprise happening. So if we test this a little bit more, did you spot that? Let's make what we had before. Here, I wanted to actually select the point that I'm hovering. And for that, I did a right-click. But right-click didn't unselect this one. It actually removed that point. So the priorities are different here. I would like to unselect first and then delete. Deleting is more troubling if you do the wrong thing than having a point unselected. So going back to this graph editor, I'm going to redo the logic here for right-click. Let's remove it. If it's selected, we unselect it. Else, if we are hovering over something, we remove the point that is hovered. Like that. Save and refresh. Yeah, and now I can select this one. Even if I'm right-clicking over something, it doesn't remove it. Okay, test it out. Let me know. What do you think? Is this a good interface? Do you want to make it better? How do you make it better? What is wrong with it? Write in the comments and let's see if we can get an even better one to work. Now, before moving on to something else, I do want to mention a little bit about code cleanup here. So this add event listeners function is kind of long. It doesn't fit on one page. That's kind of the rule. Make it fit on one page so that scrolling is not needed when looking up logic. So these event listeners for mouse down, mouse move could be extracted as their own methods. I'm going to cut everything here inside of the mouse down event listener callback and create here handle mouse down, a private method for this, and paste inside it the previous code. Now here, instead of having this anonymous function, we just say handle mouse down. And if we save and refresh and click, it doesn't work. There's an error here, and if we press here, we can see where this error happens. Let's put a breakpoint and click again and inspect this. You can see this here is the canvas. It basically points to the canvas, but we don't want that. I mean, the canvas doesn't have a graph. The graph editor has a graph. And when you exit this scope where this referred to the graph editor, now this inside of this function refers to the target of this event, to the graph. So we need to tell this function that this should be this. And the way to do that in JavaScript is with bind. Bind this. And in this way, it will send this to this function. And it's going to work again. Save, refresh, and click. And now when we hover this, it's the graph editor again. So removing the breakpoint, pressing display, the point actually appeared there. And everything still works. We do the same thing also for this mouse move. So I'm just going to cut this and implement handle mouse move for the event. Paste this here, and here let's just say this, handle mouse move, bind this. Save, refresh, and everything still works.